Hello, in this video, I will explain to you on how to find out V1 and V2 using nodal analysis. So our goal is to find out V1 and V2. V1 and V2, and we ask to use nodal analysis. Nodal analysis. And the first step that we need to do is to label all the nodes. And aside from labeling all the nodes, we also need to extract all the available information. Okay, maybe let's set this up here as our reference node. Reference node, or some other books call it the ground nodes. And what does this ground node mean? This means that the voltage here will equal to 0. Okay, so that is for the bottommost node here. Okay, and then we have these nodes here at this junction, which is V1. Okay, and then we also have another junction here, which is V2. And do we have another junction? Here we have the junction here, but there is no component that between this and the ground. So this is equal to the reference node, right? So here, the voltage here will be equal to this node here. So that will be 0. And also, I want to extract some more information from this circuit here. In this branch, we have 5 ampere current source. So it will goes up here. Then it eventually goes to the right and it goes into this node V1. And then what can we do from here? Let's see this branch here. We have a current source, a dependent one, with the direction is going up. So in this branch, the current will be going up like this, and with the magnitude of 2I1. But what is 2I1 actually? I1 is given here, right? So we will have, what is it? I will have 2I1 is equal to, we need to find the value of I1. How to find it? We can use Ohm's law, right? So the Ohm's law said that the current is equivalent to the voltage divided by the resistance. Here the voltage comes from V1, and so the current comes from V1, so I will have V1. And then the current goes to V2, so I will have minus V2. And then because we need current, we divide it by the resistance between them, which is 1 here. Good. And I think we can simplify this, so we will have 2I1, and that will equal to 2 multiplied by V1, and then minus V2. Good. And I think we have done the first step, which is labeling all the nodes and extracting all the available information. And the second one will be to assume the current's direction. So assume the current's direction. Okay, we already know some here, this one and this one. For the unknown one, we are already given this I1 here. I just follow it. So I assume this is going to the bottom here. And here I will assume that it's going to the right, and eventually it will flows here, right? So it will goes down. And one more branch here, I think we will have this, and I assume that it goes to the right. Okay, once you assume the current's direction, you stick to it. Do not change during the solving of the problem. Good. And I think we have done for all the branch. Yeah, we are already assuming all the branch, right? Yeah, we have done it. And then the third step will be do KCL for unknown nodes. Okay, unknown nodes. Here we only know one node, right? The reference node, which is the voltage is 0. So we need to do KCL at V1 and also the KCL at V2, right? Okay, let's exactly do that. So the first thing that we need to do is we do KCL at node V1. Okay, KCL said that the sum of the current that goes in is equal to the sum of the current that goes out. Okay, some other books said that the sum of the currents from a node is equal to 0, but we have to be very careful about the sign in that formula. So I like this formula better here. Okay, so let's do the V1 here. And that the current that goes in is only this one here, right? So we will have that is 5 ampere. Okay, we know exactly that is 5 ampere. And then what else that we can get from here? Nothing. There is no other currents that goes in. So we move on to the currents that goes out, which is this one and that one. For this one here, we will use Ohm's law. So the current goes from V1. So I will have V1. And then the current goes to V2. So I will have minus V2. And because this is voltage, we need to divide it by the resistance between them, which is 1. Okay, what else? This current here. So I will have plus. The current comes from V1, so we will have V1. And the current goes to the reference node here, right? Because this is connected to the reference node, so I will have V1 minus 0. And we need to divide it by the resistance, which is 2 here. Good. And I think we can just multiply both sides by 2 to get rid of this and that, right? So 5 multiplied by 2, I will have 10. And then we will have 2V1 and then minus 2V2. And 2 and 2 will cancel each other, so we will have plus V1. Okay, we can just move things around. So we'll have 2 plus V1, that will be 3V1. And then minus 2V2. And all of that will equal to 10. Good. Now let's save this as equation number 1. Okay, we still need to do KCL at the other unknown nodes, which is V2. So let's do KCL at V2. KCL at V2. Again, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out, right? And what is the current that goes in? There are two currents that goes in. Let's use another color. This one here goes into V2, and this one also goes into V2. So we will have this current here. The current comes from V1, okay, and then the current goes to V2. So I will have minus V2. This is voltage. We need to divide it by the resistance between them to get current 1. And then this current here, because this is a current source with the value of 2I1, we can just write plus 2I1, right? But then what is 2I1? We know that 2I1 is this one here from our first step, right? So we can just replace this with that, right? So we will have 2V1 minus V2. Okay, so we will have 2V1 and then minus V2. Good. And then what is the other currents that goes out? We will have this current here that goes out. Okay, the current comes from V2, so I will have V2. And the current goes to the reference node, so I will have V2 minus 0. Divided by the resistance between them to get current. So I will have 2 here. Okay, we can multiply both sides by 2 to get rid all of the denominator, right? So we will have 2V1 here minus 2V2. And then we will have 2 multiplied by 2 is 4, so I will have 4V1. And then minus 4V2. And that will equal to 2 and 2 will cancel each other, so I will have V2 on the right hand side. And we can just move things around, so we will have 6V1. And then minus 2 minus 4 will be minus 6, and then minus 1, that will be minus 7. and that will be V2. All of that will equal to 0. So this is equation number 2. So now we have two equations with two variables. We should be able to solve them, right? Which is exactly our fourth step, which is to solve the equation. And maybe let's clean up the board first, because I want to explain how to solve the equation here using calculator. Okay, let's clean up the slide first. So from our KCLs, we can get these two equations here. And we need to solve this. Actually, you can solve this manually using substitutions, eliminations, or matrix inversion, Cramer's rule, ordinary row operations, and so on. But I think the fastest way to do it in circuit analysis is by using calculator. Why? Usually in circuit analysis exam, you can bring your calculator, right? So why don't just you use it to solve it more faster? I mean faster than manual, right? So we will have this one here. Let's set this up here. So this button, and equation solver is number 5. And we have two variables here. So let's enter 1 here, because this is x and y. So that is two variables. Okay, and then we have this matrix here. All we need to do is just to input all the coefficients. For the first equation, we will have 3, and then -2, and then 10, right? And then the second equation, I will have 6, and then -7, and then 0. The V1 will be the x value here. So we'll have 70 over 9. So I will have V1 is equal to 70 over 9. But I think I will use the decimal representation. Let's just press SD here. So I will have 7.78. So I will have 7.78. And the unit here will be in volt, right? Because this is ampere and this is ohm, all in the SI unit. So this will also in SI unit. So I will have volt here. Okay, and then what is V2? Yeah, V2 is the Y value. So we will have this, which is 20 over 3, or 6.667. So I'll have 20 over 3, or 6.67. And the unit here will be in volt. And I think we have achieved our goals, because this is V1. So I will have 7.78, and then V2, that will be 6.67, which is exactly the goal of this video. Okay, thank you for watching. See you in the next video. Bye bye.